Okay, I'm gonna go get some electrical tape to fix my camera, and then we're gonna hop right back in to doing a bunch more integrals. All right, so I'm liking the focal range of like 60. All right, we got a sheet of paper and we got our minds. Let's go. Which problem were we on? Let's do 14. Oh wait, okay, wait. We were gonna do 9. 9 is the integral of from 1 to 3 of R4 ln r dr. So I think what we're going to do is u is equal to ln r, du is equal to 1 over r dr. Then we're going to say dv is equal to r4 dr. V is equal to r to the 5th over 5. And then we can do... So here we have u dv is equal to... And then we're going to have ln r over r to the 5th over 5, and this is going to be minus the integral of du, which is 1 over r dr. So this cancels to a 4. So then we're going to get... So this is going to be r to the 5th over 25, right? So then the final answer is going to be r to the 5th over 5 times ln of r minus 1 over 5 plus c. So now the question that I have is, I doubt that what we're supposed to do is... I mean, since I've done this substitution, but I don't know... Okay, wait. Let me just... This is 9. No, yeah, so you just evaluate this at, so it's going to be, 3 to the 5 over 5 times ln of 3 minus 1/5 minus 1 to the 5 over 5 times ln of 1 minus 1/5. All right, so that's the whole thing. Problem 10. Oh, wait, what am I talking about? That's not right. No, wait. That's not right at all. What's up, man? How you doing? How you doing? We are spamming integrals until my quiz on differential equations next Thursday. Because this guy, he just throws a bunch of random stuff on there. Okay, so I think what we have to do is actually, wait. How the hell do you do this problem? What? Oh, wait. That's because I'm silly. This is a minus sign. Yeah. So this is actually correct. Hold on. Okay, so yeah, I don't know what I'm doing. This was right. So you have a over x minus 5 plus b over x plus 1 is equal to x minus 1 over da da da. Then you do this and you get a times x plus 1 plus b times x minus 5 is equal to x plus 1, x minus 1. All right, so then we're going to get a plus b is equal to 1 and a minus 5b is equal to minus 1. No. Okay, so now we have the integral becomes let's see, 2/3 times plus 1/3 integral of 1 over this 1 dx and dx. So then we get 2/3 ln x minus 5 plus 1/3 ln x plus 1 plus c. There we go. Okay, and then you evaluate this, you get 4 minus 5 is minus 1. So ln, this becomes 0. And then this one, oh, wait. This is 0. This becomes 1, 1/3 ln of 5. And then this is 0. Wait. This becomes 2/3 ln of 5. So this is a minus plus 0. So yeah, so we get, in the end, we get minus 1/3 ln of 5. Very nice. Okay, let's the definite integrals are more boring, I guess. All right, we're on to 11, right? Oh, 11 is the annoying one. I don't know how to do this one. The integral of x minus 1 over x squared minus 4x plus 5. So this one, you can't factor this. So see, maybe if you did like 2x minus 4. Nah, that doesn't seem like it works either. I think maybe the best solution is partial fractions, but I don't know how to do that. Yeah, I think we're about to do partial fractions. So I think no. Partial fractions doesn't really work here though, right? Because there is no partial fraction, right? There's nothing. But what you can do is you can rewrite this as x minus 1 over x minus 2 squared plus 1. Okay, so then we get oh, but you can do this, too. Whoa, what the hell? Yeah, that's a crazy integral. That one's really tough. Because what you need to do is you turn this into x minus 1 is equal to u plus 3. Wait, no, u plus 1. So this becomes u plus 1. So then you turn this into two integrals where you just separate it out. U over u squared plus 1 du plus the integral of 1 over u squared plus 1 du. So these are actually pretty easy. Yeah, it's going to be... So wait, we need to do w is equal to u squared plus 1. dw is equal to 2u du. So then we're going to get the integral of u w dw over 2u. So this comes out to here. This goes here. So you're going to get 1/2 ln of x minus 2 plus, what is this? This is just arctan x minus 2. Wait, this is not right. This is 1/2 ln w. W is u squared plus 1. So this is going to be x minus 2 squared plus 1 in there. But then this is right. Okay, so this thing is right. Where'd you get the square root? I don't think the square root is right, though. There's no square root here. Okay, 12. Number 12. This one is the integral of x over x to the 4th plus x squared plus 1. This one is weird. You could also do maybe like x to the fourth, or you could probably do like an x squared plus 1 squared minus x squared or something. And then if you turn this into it, you're going to get u plus 1 squared minus u. And then the thing that goes away on the top. No, but how does that change anything? I don't know how that changes anything. Oh, I see what you did. Yeah, you're right. Yeah. That's the same thing. Yep. Um, but maybe at that point you can do, maybe at this point you can do partial fractions. You get 1 over, oh wait, no, it's going to be ax plus b over, but I don't get those, man. I need to practice the partial fractions where you have a, dude, these integrals are really hard. Oh wait, can you factor this? X to the fourth plus x squared plus 1. Okay, so it's saying here when you have 1 over u squared plus, you turn this into, oh, that's insane. Okay, so this becomes, this becomes 1 over u plus 1 half squared minus, or no, plus 3/4. Now, this is actually a good trick. So now that you have the integral of, so you let v equal u plus 1 half. So then you get 1 over v squared plus 3/4 dv. And then this becomes the square root of 3/4 arctan this becomes arctan of, I think it's v over square root of 3/4. I think it's that. Okay, I think that's correct. I'm not going to resubstitute everything back in. We get the idea. Oh, 13. I don't want to do 13. Damn, these are all like brutal. What the hell? If you do u equal x cubed, no, I don't think that's right. Oh, okay. All right. Square root u. You trig sub this? Wait, let me reread the trig sub thing. Okay, so you're saying uh oh, okay, so you're saying like if we wait, but it's a plus, so we do a tan. So you're saying we get like yeah, so you, like 1 plus x. Wait, but I think that this will work. But okay, but okay, I'm going to finish this and then we'll do the trig sub version. All right. So this becomes u over root u, which just becomes root u, right? So this becomes this is u to the minus 1/2. So this becomes 2 Is that right? Let me just double check that. Uh, wait, is it 1/3? Oh yeah, it's 1/3 because this cancels this. and this cancels this. Okay, so we can just get rid of that. So it's 1/3 u to the 3/2 minus u to the 1/2. And then you just plug in u equal to 1 plus x squared. All right, so that one's it. These ones where you have to, like, substitute u twice are really interesting. I probably do need to practice trig sub a little bit more, though. I'm really not that good at the trig stuff. Okay, which one are we doing now? 15. In this case, if you end up with like a... Bro, it's like I do not know how to do any of these, man. Oh my god. Okay, so this one is trig substitution. Let me read the trig sub thing again. All right, so let's just sub in x to sine theta. So if you just you're gonna get 1 minus sine squared theta, which equals cos, right? So now you have this. Now you have this on, but can you do this substitution without? Because so you still need dx is equal to cos theta d theta. Then you get dx over cos theta is equal to d theta. So then the integral becomes, yeah. Wait. Oh, no. We want, this is going to be cos theta d theta over cos squared over to the 3/2. And so I think that these cancel, right? So then we get 1 over cos squared theta d theta. So this is just is equal to the integral of secant squared. And God. I think that this is just tan. Because d dx of tan is equal to sec. So then sec squared. Okay, so yeah, so this is just going to be equal to tan theta plus c, which is equal to, wait, hold on. x is equal to sine theta. So if we have sine theta over cos, how do you back substitute? Back substituting, I guess you could rewrite this as sine over 1 minus square root of 1 minus sine squared. Okay, that's how you do it. Okay, the back substituting is a little confusing here because then you have to yeah, this is trig sub. Okay, so now we have x over 1 minus x squared to the 1/2 plus c. I think that's the whole thing. That was a good one. Trig sub is tough stuff. Okay, this next one. It's the integral from 0 to 2 root 2 x squared over 1 square root of 1 minus x squared dx. But if you trig sub in here and you get x equal to sine again, then you get sine, then you're going to get dx is equal to cos theta d theta. But then you're going to get this. Oh, wait, but you know what you can do? You can do sine squared theta times cos theta d theta over, this is going to be square root, this is going to be 1 minus sine squared, this is going to be cos, so this is just going to be cos. So these cos cancel, and then you're just left with the integral of sine squared theta d theta. And we have to do this, we'd have to do the change of whatever, but I don't want to do that quite yet. I just want to get the, so now the integral of sine squared, maybe you can memorize it, but I wonder if you can do a, I wonder if you can do like a u integration by parts or something, where you have like u equals sine squared theta, but then you have like a v is equal to d theta, or dv is equal to d theta, v is equal to theta. Then you do the du. What is the derivative of sine squared? Derivative of sine squared d theta of sine squared theta is equal to, it's going to be 2 sine cos, 2 sine theta cos theta, right? Oh, that's not going to work. We're not going to be able to do that. Yeah, but what's the identity? It's not going to be the, dude, I don't remember these identities. Turning it into cos doesn't help. All right, I'm gonna figure this. Okay, so how to integrate sine squared x. Oh, you do the half angle? Oh, okay. All right, so apparently, but how do you? All right, let's look at this. How do you derive the half angle? Start with the double angle formula. Wow. Okay. All right, so let's just use the formula then, because that formula is crazy. All right, so you can rewrite sine squared theta into 1/2. What is it? Plus or minus? Minus 1/2 minus cos 2x over 2. So now we can just take the integral of 1/2 d theta minus 1/2 integral of cos 2 theta d theta, which is equal to theta over 2 minus, and then this is going to be minus 1/4 sine 2 theta. Maybe? Let's see. Nice. All right, we did it. That was a good one. I feel like I'm capping out on integrals. Holy cow. So I don't think that my choices are going to work. So I think I want to try, let's see, what's the half angle? What's the cos power reduction? Oh, okay. So if we turn this into t times 1/2 t times 1 plus cos. Okay, if we let I think we should let u equal t dt, and then du is equal to, wait, what the hell? This is going to be plus. So wait, but that's but we also need, so there's still 1/2 here, so there's another 1/2 here. But then there's also a plus 1/2 1/4 t squared. All right, something like this, I think. Okay, cool. So you do the power reduction. All right, so we got this t squared over 4. And then we got this 1/4, 1/8 t sine 2t plus cos 2t. All right. I think we got it right. Nice. That's like the first one I've gotten right in forever, man. So this is problem 18. E to the square root t over square root t dt. So I'm thinking if we do this, because we don't have to substitute this, we can just let it be e to the u over root t times 2, let's leave this 2 here, root t du. And then we just kill this. Isn't this easy? So then we can just was that easy as hell? What? All right, yeah, that was easy as hell. All right, cool. Ooh, this one looks fun. 19. Hold on, let me turn on my phone. I can't see chats for some reason. Someone's chatting, I can't see it. Okay, hold on. So this is going to be the integral of e to the x plus e to the x. Yo, that's crazy, man. All right, so I think what we want to do, if u is equal to x plus e to the x, then du is going to be equal to 1 plus e to the x dx. But then you have this, like, 1 plus e to the x down here. Well, you could also do this. Isn't e to the x plus y equal to e to the x times e to the y? So then we could rewrite this as e to the x times e to the y, or e to the x. I'm gonna think about that. Yo, oh my gosh, bro. It has been a while, Ole. I can't see, for some reason I can't see your chat on my computer. Dude, it's been so long. How have you been, man? Bro, I am in these 2 classes that are kicking my ass, man. Wait, when did you send me something on Discord? Wait, what'd you send? Oh, the painter? Dude, I have not, bro, I'm so sorry, man. I have not had any time to work on the any projects but homework. It's just been a total grind. It's really unfortunate, actually. Dude, I am so sorry, man. But yeah, I've just been doing homework like crazy. This professor I have, bro, he, holy cow, man. He his homeworks, he gives like 1 or 2. Yeah, bro, I know. I think I'm gonna have more time starting. This is gonna sound brutal, but starting June 27th, I'm gonna have more time. I have this crazy summer class where I'm doing like 9 to 5s, but then after, well, okay, 2 days a week it's gonna be 9 to 5, and then 3 days a week, it's going to be 9 to 12. So I'm going to have, and then in the late summer, I'm going to have a ton of time. And I want to try to start some of the biology stuff. Maybe actually finish up the drawing robot. That would be fun. But until June 27th, I am grinding so that I don't, get a terrible grade in this class. So no, I'm not on Mars yet. All right. So if e to the x, if we sub u equal to e to the x, then we're going to get u times e to the u. And du is just equal to e to the x dx. Oh, this is going to work out really well. Okay, so wait, hold on. So we're going to get e to the x times e to the u times du over e to the x, and then we can cancel these, and then we just get e to the u as the... Wait, is that right? That's crazy. So this is just going to be e to the x. Oh, wow. That's a crazy integral. E to the... Okay, so let's see. Dude, what have you been up to, though? You still around? What are you doing? Have you worked on any cool Rust crates yet? Or, since I talked to you? Okay. Yes. All right. So this is it. E to the x plus c. All right. Problem 20. Crazy how long these integrals take. 20 is... Oh, what? 20 is e squared dx. This is just going to be e squared x plus c. 21. Okay, here we go. This is a good one. A tan square root x dx. Okay, so you can't really just u sub the square root x, because then you get another term. I feel like they just want you to memorize it on this one. Let me think about that. A tan square root x. What does that even look like? I want to plot that one. A tan square root x. I feel like this could be an integration by parts one, but actually that doesn't make any sense. Okay, I don't know how to do this. Oh, you do? Oh, this is a crazy one. Okay. All right. So I got the hints, but let's just like go through the motions. Okay, so this is going to be, so you do u is equal to square root x, which implies that u squared is equal to x. So then dx is equal to 2u du. Okay, so then we can rewrite this as a tan u 2 times 2u du. Okay, now we can do an integration by parts. So we probably want u equal to a tan u. Oh, wait, let's call this w. Okay, so then we have u is equal to a tan w, and dv is equal to 2w dw. Okay, so now du is going to be equal to, all right, so I'll never remember this. I think it might be like 1 over 1 plus w squared dw. Wait, if that's the case, then this might not work out. So, okay, so if we have tan u equal to w, we're going to get u prime sec squared u equals w over sec squared. This is going to be equal to w over 1 plus tan. I've done this like 1,000 times today. Sec equals c over a. Tan equals b over a. So if we have c squared is equal to 1 Yeah, that's correct. So sec is equal to 1 plus tan squared. So then we're going to get w over 1 plus w squared. Oh, wait, this is a 1 because you take the derivative of this. So this is, d, yeah, so I was right, actually. This is true. But, that's kind of tricky one. What if, okay, wait, let me just write out what it would be. So we'd have, and then v would be equal to w squared. So we'd have, so this would be u dv is equal to w squared a tan w minus the integral of v, which is w squared du, which is 1 over 1 plus w squared dw. I think we might be able to make this work, actually. We could do like, so then we have a minus 1. So this is just going to be 1 minus 1 over w squared plus 1. Oh, yeah. So this is, okay, so this is equal to w squared a tan w minus integral of 1 dw minus integral of 1 over w squared plus 1 dw, which I think that this is just going to be w. So minus w plus a tan w. Okay, so this is going to be w squared a tan w. Is that right? It seems off. So what was w again? W is square root x. So this is going to be x a tan square root x minus square root x plus a tan square root x. Oh, let's go. All right, that one was great. We did it. We did it, family. That was a tricky one, man. Holy crap. Dude, these integrals are insane. It's like, when does this stuff even show up, man? ln x over... Oh, I know what to do. 1 plus ln x squared to the 1/2. I think I know what to do. I think we want to do I think we might want to do like a ln x equal to sine theta conversion. Do it implicitly. We get 1 over x dx is equal to cos theta d theta. Oh, this might work. Holy shit. Because this is a dx. So then this becomes dx is equal to x cos theta d theta. So then when we transfer this over, this x is going to cancel. So then this becomes theta. Wait. Sine theta over 1 plus sine squared theta to the 1/2 x cos theta d theta. So then this cancels this x. And then so then this is going to be equal to sine cos over cos. So this cancels. And this just becomes sine. Holy shit, bro. No way that's for real. So then this is just going to be minus cos ln x plus c. If I'm right, dude, I'm so happy. So wait. I didn't get it right at all. Like, not even close. What did I do wrong though? Can't you do this implicit differentiation thing though? But you could also do that. Oh, that's so weird. Oh, you know why though? Wait, no, you know why? Because I just totally bungled this, right? Because if you have sine, because this is not right. That's why. Because this 1 plus, I think you need to make it tan. I think you need to make it tan, and then it all messes up. Because 1 plus doesn't make it work. Let's go to trig sub. Yeah, so if you try to make it tan, but then you would get... All right, I want to try it, just for the hell of it. ln x is equal to tan theta. So then we're going to get 1 over x dx is equal to secant squared theta d theta. So then we're going to get x secant squared theta d theta is equal to dx. But see, that's where you run into some trouble, right? Because you're going to get... So the thing cancels out, so you get integral of sine theta... no, sorry, tan theta. And then you end up with this 1 plus tan theta, which becomes secant 1 plus tan squared theta is equal to secant squared. Okay, so we're going to get sec squared theta to the 1/2. So that just becomes sec. This is tan. This is sec squared. The x cancels, and this is just going to d theta. So then this cancels this. So now you're just left with tan theta sec theta d theta. But if this is b over a times c over a, I don't really know what you can do with that. I feel like there's probably something you can do with that, but I'm gonna just see what that is. Integrate tan x cos sec x x. So this becomes... Oh, really? So this just becomes sec x. So that, but then that becomes, or sec theta. So that becomes sec ln x. I don't think that's right. Damn. All right. So wait, we're gonna... So I don't know why that failed, but it did. All right, I'm gonna be right back. All right, I'm gonna try something. I don't know how the audio is gonna go. Oh, what's up, Nell? What's going on, bro? Okay, so wait, hold on. Let's walk through this one because I just did it on the whiteboard. I'm gonna try to reset up my camera to point at the whiteboard because I want to stand. I feel like I've been sitting all day and I'm sick of sitting. But okay, we're gonna do this integral. I just did it on the whiteboard. Ln x over x 1 plus ln x squared to the 1/2 dx. We let u equal to ln x. So du is equal to 1 over x dx. So then x du is equal to dx. So now what we can do is we can rewrite this integral as u over x 1 plus u squared to the 1/2 x dx. So we can du. So we can cancel this. Okay? Now we can rewrite this as v is equal to 1 plus so it's just so interesting how these rules the path that these rules get applied. Anyways, we do this. dv is equal to 2u du. So then we're going to get dv over 2u is equal to du. So now we can rewrite the integral again. U over v to the 1/2 times, and we put the 1/2 here for this thing, and then we get dv over u. These u's cancel. Now we're just left with the integral, 1/2 of the integral of v to the minus 1/2, which is equal to v to the 1/2, which is equal to square root v. V. Square root v is equal to 1 plus u squared to the 1/2, which is equal to square root 1 plus ln x squared, and that's our plus c. That's our big final thing. New sub, let's go, dude. I'm trying to hit 400. Let's go, man. All right, I want to try something out though. All right, we might not have any audio because I don't want to move my laptop, but let's just see if we can. All right. Oh wait, but it's flipped. I gotta unflip it. Hold on. Transform. All right. So now, let me just go get my iPad. All right. Let's go. Oh, I have plenty of room. All right, let's check if we got the right answer on that one. That was actually fun because I felt like I knew what was going on, but I also don't trust that I actually got it right. Um, um, oh, I did. I did. Uh, right. I know what happened. Okay, so that number is actually close. But what happened was, okay. So I'm not gonna redo the whole thing, but I'll show you. Okay, so it was just a mistake in the polynomial long division. Other than that, the integrals looked good. That was fun. All right, next one. Let's keep it moving. That one was easy. Oh, you can't even see it. Hold on. All right, I need a hint. I don't get it. I don't know what I'm doing. I'm skipping that one. I don't understand what the hell is going on that one. Skipping it. All right. Sine square root t. Nice. Damn, I have no idea what I'm doing. Oh, it's a fucking inverse hyperbolic tangent function. Yeah, okay. Well, that's why I was having trouble. Okay. But but you don't even need that. Or you just do integration by parts, I guess. Okay. Okay. How do we do it? Wow, okay, that's a ton of algebra. Holy shit. How did they do it though? 1 plus x over u, I guess. Or not u, but whatever we're gonna call that in the square root. Divided by x plus. Yeah. Damn, that's a really challenging algebra problem. All right, so I'm just gonna get the answer then. It's 1 over. Yeah, okay. All right. Are you supposed to integrate by parts again? Wait. Oh, wait. Seriously, just that? That's wait, no. Oh yeah, because the rest of right. I swear, man, these are too hard. I have no idea what I'm doing. Oh. What the hell? That's a crazy use sub, bruh. See, I don't know how I'm supposed to come up with this stuff. It's so clever. It's just so damn clever. How do you separate it? Oh, yeah. I think I'm starting to cap out. I think I'm just like I think I'm just too tired to think anymore. Like how did that even happen? Yeah, I flipped the minus sign. All right, I think that's enough integration. I can't even do them anymore. I wish there were some easier ones, dude. These are all too hard. These are fucking psycho, man. That's so weird. That's so weird that e to the x squared just doesn't have an just you. I don't know, man. It's so crazy. Let's see if we got some easier ones. Let's do some of these. These have got to be easy, right? Then the first, this one. How do you do this one? I don't even know how to do that one. You fact? Oh, you do you do a factorization and then a decomposition, maybe? So you get like 2t plus 1 plus t plus times t plus 1, and then okay, maybe we'll try some of these. Hopefully, a few of these are easier because um, those other ones were so tough, man. What the heck? All right. I am not convinced, really. See, derivatives, I'm not like, what's going on? But with integrals, it's like, what the hell? The partial fraction seems right, though, right? Oh, god damn it, I did it wrong. What? Oh, because I did it wrong. Come on, man. B equals 1, A equals minus 2. Hold on, what? Oh, yeah. Fuck. Holy crap. I should end this stream before I embarrass myself even more. It can't be worse than it already has, but how am I getting this so wrong? So then, oh my gosh. Wow. Yeah, holy cow. Because I'm forgetting also to do the chain rule. Or wait, not the chain rule, but yeah, I'm skipping so many steps. That's what's happening. Because like, all right, if we go to, all right, because let's go do this. Jeez Louise, bro. Jeez Louise. All right, let's see. Is there any other good ones? All right, I got a couple of good ones, and I think I can do them properly. There's no way I got that one wrong. I hope. Nice. Okay, let's do the next one. I think I'm right. I think I'm right, but I don't know. Honestly, anything goes with these fucking things. Which one did we just do? 12. Okay, I think that's right. Right? Like, I mean, the only thing that's not crystal clear is this. Oh yeah, dead on the money. Let's go. That's what I'm. That's what I thought, baby. Okay, let's do. Okay. Spamming integrals, bro. It's spamming them integrals, bro. What fucking spamming them integrals? How confident am I about this one? 50-50. God damn it. What did I do wrong? Oh, come on, man. I'm so okay. Yeah, I mean, okay. What's cool about today is that it's shown me just how many gaps in my knowledge of just doing this sort of basic elementary function manipulation and stuff like this. I mean, because all this stuff is important, right? You know, polynomial long division, that's pretty sweet to think about. You know, I mean, if you're talking about, polynomial rings and all sorts of stuff, whatever, unique factorization domains and stuff, proving that the ring of polynomials, all that stuff is, so it's nice to know this stuff just symbolically, from a computational writing them down, but God, how did I do this wrong? Okay, wait, let's just fix this. So All right, so it's just something that I have to remember that, like, I have a problem with polynomial long division or something. All right, come on, keep it up, keep it up. Okay, so did I get it right or not? I don't know. Let me figure that out. So that was this one. This one was pretty straightforward. I don't know how I could have really done it so wrong. Yes, let's go. All right, perfect. Got it exactly right. All right. All right. Next integral is All right, so we're like so close, right? We just don't know. We just don't know what the integral of secant is. The integral of secant might be, I don't know. Let me look it up. I don't know what it is. Yeah, I don't know how to derive that, dude. That's nuts. The natural log of sec x plus tan x. That's crazy. Let's double check. It's like, what is the point? You know? What the hell is the point? All right, let's double check. Did I get it right? Yes, I did. I just needed the last little bit of help, which is looking that integral up. But for the most part, we did do it. You know, it took us a little bit to figure out what to use for the integration by parts. Um, and we knew that because when we took the derivative of sec, we got tan sec. But that's the only way we knew how to integrate dv. Okay, cool. This is crazy, man. This is very crazy, boy. I'm guessing I got like, I mean, I'm like 50-50 on this one. Because what happened was I realized that when you have multiplicity in the denominator of the partial fractions, you don't multiply by all of the denominators. You just need to multiply by oh yeah, duh, that's obvious. Yes, you multiply through by this x squared plus times x plus 3. Okay, looks like I got the ABC right. 3 over okay. 3 ln x plus 1 over x minus 2. Oh yeah, let's go. All right. I'm feeling pretty good, man. All right, we did like 6 hours of integrals today. I think that's going to be the last one. All right. I'm tired of doing integrals, but I feel like I do feel better. I do feel better about, I think I'm weak on trig substitution. I'm a lot better on integration by parts, but some more practice wouldn't hurt. Let's see, what other tricks are there? I think U sub. I'm okay at U sub, but there's some really weird U subs that we encounter. I mean, section 7.5 has some crazy integrals in it. I'm not gonna lie. Oh yeah, and then memorizing some of the weird formulas are particularly like the secant, cosecant, cotangent, stuff like that. And for hyperbolic, actually hyperbolics are going to be pretty easy because they're really clean. I don't know. I just don't know what's going to be on this test, so just spamming integrals, I guess. Let's see. How many other good ones are there? I think a couple more sessions like this though would be good because I feel like if I'm just doing it only like for a few days, like I need to do it before the test too. Just remember some of the good integrals, some of the ones that, and then review the test. But all right, that's where I'm gonna leave it with a correct answer of a partial fraction decomposition integral. I think I'm okay at partial fractions. I'm weak at the long division, the polynomial long division. Just because I'm so rusty that I always flip the sign. But I think I could do it if someone, if it was high pressure, I could do it. I think. All right, so thanks for tuning in. That's another day of Anand's integrals. Come on, baby, let's go. All right. The thing is, man, I really want to get back to doing. It's I just maybe it's just because I'm like I feel like this is beneath me to just do integrals, but like because I want to get back to real math, dude. Just doing integrals, I don't know. It doesn't really feel like math. It just feels like a bag of tricks. Hey kids, come get your tricks. Some weird shit like that. But I want to get back to my theory of computation book. I want to get back to linear algebra. Some of the more proofs, some of the more theoretical linear algebra. Even just get back to doing differential equations. But that differential equations book is starting to bore me, bro. We're just talking about systems and geometry and vector fields and stuff like that. Kind of boring to me. I don't know. But all right, that's it. Peace.